Alright, welcome to Chapter 10, Section 2, called the Pythagorean Theorem and its Converse. This is for Integrated Math 2, or IM2. I am reusing a few of these videos from previous videos, so the problem numbers might not match up perfect, but they are in the correct order. As always, a couple things you'll see on the main screen here. You'll see a due date on your student screen. I don't see it on the teacher preview here, but you'll see it on your student screen. The second thing are the number of attempts. You always have unlimited attempts on your homework assignments, your quizzes, and your tests, so you can come back in and try them as many times as you would like. Number of questions is 4 questions for this particular assignment. For grading policy, it's always best score, so whichever attempt is the best one is the one you get to keep. And partial credit is always enabled, so if you answer 1 of 4 questions correctly, you get credit for the 1 question, or however many you answered correctly. Down here it says once you start your homework, you must finish it before you can work on anything else. And what that means is once we click the start button, down in the bottom right corner here, we will have a submit assignment button. We need to make sure that we click that button if we're ready to leave the screen. So whether or not we've worked on anything at this point, or if we've only worked on a couple, or maybe all 4, we click submit assignment. Make sure that you have in fact typed the answer in and click check to save your progress, because once you have a green check mark, it saves that for you. If you don't have the green check mark, it doesn't save it. It's going to make you do that again. So always make sure you finish the problem, and it will come back to wherever you clicked the submit assignment button. It's not going to make you redo anything that you've already completed. But clicking that button stops the program from locking you out of all of your other assignments, just like that other screen said. And it affects the grade book, so your teacher can actually see what you've been working on. Until you click submit assignment, you're basically, your account's frozen a little bit. We don't even get to see what you've been working on. On the side here, we do have a calculator. That's not always available, but sometimes it's there. Explanation will tell you you're going to lose your question attempt because it's literally going to explain this question. It's going to give you the solution to this question. So it's not going to tell you the answer unless you come type it in. Then we have example. This will show you exactly what it is we're going to be working on here. So Pythagorean Theorem, we'll go over that in just a second. And hopefully it doesn't look brand new. I know I think we've learned it before 8th grade at this point. And then message center, so you can message your teacher directly from the screen. It'll attach a picture so that your teacher knows where to come help you. All right, let's go ahead and take a look at Pythagorean Theorem. So Pythagorean Theorem is actually a little bit, it comes from the distance formula, which we will get into the distance formula in the next couple sections. First, we start with Pythagorean Theorem. So this is a way that we can find a missing angle of a right triangle. And remember, right means that it's got a 90-degree angle on it. So if we have a triangle, and it's got the 90 degree, and I'm just drawing this guy here, the 2 legs that make this 90 degree, so I'll put this in blue even. So here's the 90 degree. The 2 legs that create that 90 degree are called A and B. It does not matter which one is A and which one is B. Truly does not matter. They just need to be the legs. Across from the 90, so the leg that's across, the side that's across, that's not one of the legs, is the C. That does matter. That has to be the C. And we call this the hypotenuse. So we have the legs and we have the hypotenuse. So hypotenuse, hopefully I spelled that correctly. Looks like I did. And then we have the legs here. So we have leg A and leg B. And the Pythagorean theorem says that if we have a right triangle, then A squared plus B squared equals C squared. So again, hopefully that sounds somewhat familiar to you. I know when I get to the high schoolers, this definitely should sound familiar. But for 8th grade, I can't remember right off the top of my head if this is the first time we're seeing Pythagorean theorem or if it's something that we've seen in the past. Sorry, my math knowledge gets a little bit shaky when I go below the 8th grade because I don't fully know exactly when things are introduced at a lower grade level. With these 2 pieces, if we know any 2 of them, we can solve for the other missing piece. So in this case, we know that we have 12. So we have 12 and we have 16 on this one. And I'm going to erase these just so I can, keep this diagram here. So my A and my B are 12 and 16. I need to make sure I square them. And that's going to equal C squared. Like this. So now I'm going to go through and I'm actually going to square these. So they do give us this calculator. So I'm going to go 12 squared plus 16 squared. And this should be 144, and I believe it's 256, I think, unless I'm totally off. Let me see. 16 squared. Yeah, 256. 256 equals C squared. C squared. And then we saw that equaled 400. So the nice thing with this calculator is that you can type in more than one thing. You don't just need to do 12 squared and then 16 squared. You can do that on the smartphones too, but I've noticed it like on my iPhone. I don't get to see what I'm typing in. It doesn't save it like that, where I can actually see, 12 squared plus, minus, I don't know why I put minus, plus 16 squared. So my smartphone doesn't show it to me like this. I think Androids actually do, but iPhones don't do it, which I kind of prefer. I like being able to see this piece here that I've typed in. So I get 400. And what we need to do at this point now is we need to do what's called taking the square root, because this is C times C. That's what this equals, C times C. So if I have C times C and that gives me 400, what I want to know is what times what, the same two numbers, will get me 400. And this is called a square root. I want to break it apart into the same two pieces. So we can use a very nice little symbol called the square root symbol. And so the square root of C squared would just be C, because C times C gives me C squared. So I'm basically saying what number multiplied by itself gives me this number. So C times itself gives me C squared. So if I take the square root of 400, and since I had it highlighted, I can just click this button. I know there's not a 2 here, so that's another thing to keep in mind. When we see this and there's no number, it actually is assumed there's a 2. Otherwise, we'll see the number there, like that. So there are more than just square roots. There's other types of roots too that we can do. So this is 200. So, sorry, 20. 20 times 20 gets me 400. So 20 times itself. So again, when I say what is the square root of a number, I'm asking what number can multiply by itself to get this number. So 20 times 20 can multiply to get 400. All right, 20. Check. Yay. Continue. And this is directly related to the distance formula, like I said, and we'll get into that. I believe it's either section 6 or section 7. I'm trying to remember which section it is. Section 7. We'll get back into the distance formula, and we're actually going to use Pythagorean Theorem to show the distance formula. So it'll make a little more sense when we get there, I think. All right, so with this one, now I have A, B, C. Again, this could be A, this could be B. Doesn't matter which one's A or B. But C is very, very picky. It has to be that one across. So now I know what my C is. So I have A squared plus B squared equals, and I don't know why I erased that guy, C squared. All right, so now I'm just going to go ahead and say it's AB, just because I have it labeled that way again. It doesn't matter that the triangles don't quite match. It's the legs of the 90 that make that A and B. So 10 squared plus x squared. So I have 10 squared and I have x squared. And that's going to equal C squared, which is 16 this time. I have the C at 16. So we did 16 squared in the last one. That was 256. Equals 10 squared is 100 plus x squared. So now I want to get x squared all by itself real quick. And 100 minus 100 cancels. X squared equals 156. Like that. And it's telling me to round to the nearest hundredth. If you know your squares, you might already know this isn't going to give us a nice clean integer. It's going to be kind of a funky number because 156 is not a clean square. So remember, this is x times x. So if I take the square root of this number, which I think I did in green last time, x can multiply by itself to get x squared. So x is the square root. Same thing with 156, but there isn't a whole number that I can break it into. And because they're telling me to round to the nearest hundredth, that's also a clue I'm going to have a decimal answer. So I'm going to, with this one, if you're doing this on a smartphone, you actually type the number in first and then click the button. But if you notice if I do that here, it doesn't do it quite right. So I need to make sure that I click the square root button and then type that in. Now you could, if you typed it in first and then you highlighted it and clicked the button just like it did on the last one, it'll put it in the right spot for you. So there's a way to fix that, but again, depends on which device you're using, how you type it in. So let's go ahead and equals, and it wants to the nearest hundredth. So the hundredth would be right here, this 8. But I'm going to delete these really quick. We need to look one past where we want to round to and decide if we're rounding up or down. So if it's 5 or bigger, we're going to round that 8 up. If it's 4 or less, we round it down basically just by getting rid of that extra decimal place. Well, since it is 5 or bigger, this is going to round to a 9 like that. So it's going to be 2 or 12.49. Check. All right, so we're still using the Pythagorean theorem. We learned all about that in section 5. And so with Pythagorean theorem, if we have a right triangle like this, then we have the sides that create this 90 degrees. So these two sides here, these are A and B. Does not matter which one is A and which one is B. What does matter, very, very important, is the C. And the C has to be the one that's across from the 90 here. It's the largest side. So the A and the B are the two smaller sides, and the C, which is the hypotenuse, is the larger side. And what Pythagorean theorem tells us is that A squared plus B squared, so the two smaller legs, are equal to the larger side, and they're all squared. So A squared plus B squared equals C squared. So we're going to use this, and we're going to use it on a diagram just like we see here. So the length of the shadow of a building is 27 meters. So here's the shadow, 27 meters. The distance from the top of the building to the tip of the shadow, so the top of the building to the tip of the shadow, is 35 meters. Find the height of the building. So they have that question mark there. That's what they want us to find. And then round your answer to the nearest tenth if necessary. So we might round, we might not round. So in this case, if we're looking at this piece, 35 is going to be our hypotenuse, our C, and 27 is going to be this B on the bottom here, right? So what we're looking for is the height, which in my diagram is the A. So we have A squared plus B squared. Instead of B squared, I can just replace that with 27 because I know that's the length of that bottom one. And that's going to equal C squared, which we know what C is also, it's 35. All right, so now we're going to go ahead and pull out the calculator here. So we have 35 squared, and we get 1,225, and that's going to equal A squared plus, what's 27 squared? Whoops. 27 squared equals 729. All right, now I want to get A squared by itself, just like I would any other variable. So I'm going to subtract 729 from both sides. Let's see, we get 1,225 minus 729. So we get 496 equals 729 minus 729 cancels. So we get A squared. So now this is the point where we need to take the square root of a number. So remember square root, I talked about this quite a bit in the last section as well. What a square root means, if I'm squaring this number, it means a number times itself will give me this number. So in this case, for A squared, it could only be A times A. So if I want to know what the square root of it is, I'm saying what number do I multiply by itself to get this number? Well, I'd multiply A, so the square root would be A. So I want to do the same thing with 496. As long as this is highlighted and I click this button, it'll work out nicely. It'll put the square root where it's supposed to be. If the number wasn't highlighted, it would actually put it after, like this, and we don't want it after. So just make sure it comes before the number, and then we'll go ahead and equals. And we are going to need to round because this is definitely funky. So we want to round to a tenth, so I'm going to delete everything. I want to go one past the number it's asking me to round because I need to look at this number. If it's 5 or bigger, I'm going to round up. So I'm going to round the tenth up, not the 7. The 7 tells me what to do. I'm looking at the 2 to determine, am I rounding the 2 up or am I leaving it 2? So since 7 is 5 or bigger, I'm going to round this up to 3. So it's going to be 22.3 meters tall. All right. Next. Determine whether a triangle with a given side length is a right triangle. All right, so this one has to do with another rule when we're looking at these ones. So any two sides of a triangle have to be smaller than or equal to, the third side when I square them. So we're just going to use Pythagorean Theorem again to look at this piece. So if I have, and it's the two small sides, you're not going to do the large side plus the small side. The legs are always smaller than the hypotenuse. I don't know if I said that at the beginning, but that's true. The hypotenuse is always the biggest side. So we're just going to test. If I square the two small sides, do they equal the large side squared? So I just want to go through and test that and say 12 squared. Oops, why is it not typing? I have too many wires here getting in my way. 12 squared plus 15 squared equals, we get 369. 20 squared, we did this earlier, that's 400. If you didn't remember, you could always go 20, oops, that's, darn it. Hitting the wrong buttons here. Back, squared. So that's 400. So they do not equal each other. So this would be not a right triangle. So far when I've done these, I have not clicked on not enough information, because as long as they give you 3 lengths, you have enough information to at least test this. All right, so for the next one, it's 9 and 12. So we have 9 squared plus 12 squared equals 225. So as long as 15 squared is 225, which it is, then they are equal. That means that it's a right triangle. So it's the two smaller sides squared and added together need to equal the larger third side. So now we're going to go back here and we're going to try it again. 15 squared plus 36 squared. And that gives me 1,520, or sorry, 1,521. Yeah, I was saying that right. And we're saying, does that equal 39 squared? Oh, look at that, it does. So yay, those are also right triangles. So let's do this last one. We have 10. I didn't mean to do that. Undo. I don't know how to clear the memory. That's all right. 10 squared plus 12 squared. So we get 244 equals, if you remember 16 squared, it's not 244. It's 256, I believe. Clear one. Oh my goodness. I can't seem to hit the right buttons here. There we go. Yep, 256. So again, that does not equal each other. So that would be not a right triangle. So this one, we're just checking, does it in fact work when I use Pythagorean Theorem? And again, make sure it's the two small sides, A and B are the smaller sides, the legs, and it's squared equal to the larger side, which is C, or the hypotenuse. All right, so in this one, we're going to take a look at, we're demonstrating the converse of the Pythagorean Theorem, which is what this topic is called. So below are two triangles with their side lengths shown, and we're going to answer the questions about each triangle. So compute the sum of the squares of the shorter lengths. So we have 9 and 10. Those are the two shorter lengths. So we have 9 squared and 10 squared, and they do give us a little calculator here if you need it. So we have 9 squared, which is 81, plus 10 squared, which is 100, so that one's not too terribly crazy. So we have 181. And then down here it says compute the square of the longer side, so that's 144. So what kind of triangle is it? Well, when we're looking at the triangle inequality theorem, which we were looking at, I believe, on the very last, on the very last problem we were actually just looking at whether or not it could be a right triangle. So when we're looking at the converse of the Pythagorean theorem, we're actually looking at it as c squared is something, and then we have a squared plus b squared. So, and we have three options here, like this. And I know this is in yellow, so this is very nice coloring here. So if we have it where, I'll do blue, I guess, just so that it's a little darker. If we have c squared that's larger, so c squared is larger than the other two, then we have it as obtuse. This is not a right triangle, it's an obtuse triangle. If c squared is equal to a squared plus b squared, then it's a right triangle. If c squared is less than a squared plus b squared, so these two are larger when we square them and add them together, then it's an acute triangle. So it's just a very quick way to classify a triangle when we look at the side lengths and how they are together. So with this one, we have 144 is smaller than 181. So we're definitely in this acute area here. So this is an acute triangle. So we're going to do the same thing on this other one. So we have 7 squared plus 15 squared. So we get, that's not what I want to do, 49 plus, I'm trying to remember, is it 225? It's going to just do it for me, but all right, so we get 274, and then 18 squared equals 324. So 324 is bigger than 274, so c squared is bigger than the other two added together, so we're in the obtuse category there. So it's just a way, we do need to know these pieces, but we're always kind of looking at the c squared. Is c squared bigger? It's obtuse. Is c squared smaller? It's acute. Is c squared equal? It's right. So we're kind of always comparing, if you focus on the c squared, what is the c squared compared to the others? Then it makes it a little bit easier there. For each set of the three lengths, determine if they can be the side lengths of a triangle. So for the triangle inequality, 3 side lengths can form a triangle if and only if the sum of any 2 lengths is greater than the third side. So what we need to do is make sure that when we add 2 sides, it's always greater than the third side. If we find one of those to be false, then it can't be a triangle. So we're literally just going to go through and go 8 plus 6 is greater than 24. 6 plus 24 is greater than 8, and 24 plus 8 is greater than 6. So if any one of these is false, then it's not going to be the side lengths of a triangle. So right away I can tell, well, 8 plus 6 is not greater than 24, so this is not the side lengths of a triangle. So same thing with this next one. I have 15 plus 12 is greater than 4. That's true. 12 plus 4 is greater than 15, not by much, but still true. And then 15 plus 4 is greater than 12. All of these are true. So only these two were true on the top. But as soon as I find one that's false, I say no. But if they're all true, then it can be the side lengths of a triangle. So we're just testing, can it in fact be the side lengths of a triangle? So we have 4 plus 15 is greater than 16. That's true. 15 plus 16 is greater than 4. That's true. And then 16 plus 4 is greater than 15. So again, they're all three true. So yes. And then we have 9.1 plus 2.9 is greater than 5.4. Well, that's true. 2.9 plus 5.4 is greater than 9.1. Well, let's test that. So we get 9 plus 4 is 13, and then 5, 6, 7, 8, so it's 8.3 is greater than 9.1. That's not true. I don't even need to write the other statement. I know that's not true. So I can go ahead and click check, and we're good to go there. So, all right. So in this one, it's asking us to find the area of a right triangle, and be sure to include the correct unit in your answer. So this one's kind of randomly thrown in here. We haven't been doing area for this whole section, but there's a reason they're throwing this guy in. We have a right triangle, and we need to find the area. So what is the area of a triangle? Well, it's 1/2 base times height. When we're talking about a right triangle, the base and the height are the two legs that make the 90s. So if we kind of flip this around a little bit, I have the base here, which is 6, and I have the hypotenuse that's across from the 90 here, which is 10, but I don't have this missing piece. This would be my h. So I have my base, I know that's a 6, but I need my h. I need to know what am I multiplying that by to get my area. And that's going to be multiplied by 1/2. So I'm missing this piece. How can we find that missing piece? Well, what have we been doing for most of the section? Pythagorean Theorem. So I'm going to go through really quick and go a squared plus b squared equals c squared. It's a right triangle. I know they're equal. So I have h squared plus 6 squared equals 10 squared. A squared plus b squared equals c squared. And really, a and b don't matter which one is a and b, but c does matter. C has to be across from the hypotenuse. Remember that. That's the big one. So h squared equals 36 plus 100. I just squared 6 and 10. I'm going to subtract 36 from both sides. I get h squared equals 36 minus 36 cancels. And we end up with, I think it's 64, I believe. I want to make sure I didn't do that wrong. Haven't had quite all of my coffee this morning. There we go, 64. So we're good to go there. So now we're going to take the square root of 64. And remember, when I'm taking the square root of a number, what I'm asking is, what number is multiplied by that number to get it? So I'm taking the square root. So if I'm looking at h squared, well, it's h times h. So h is the square root because h was multiplied by itself. And for this one, if I want to take the square root, if I didn't know my square roots off the top of my head, again, this might be a really good one to practice if you don't know it already. Because, up to, maybe about 14, 15, it's very convenient to just know these ones. But you can also just use your calculator here. If you have it highlighted already, it'll go in there. If I didn't have that highlighted like this and I clicked it, it's just going to go in, wherever. So I want to make sure that I have it highlighted so it goes in the correct area. Or click this and type in 64, and it'll tell me that the square root is 8. So 8 times 8 gives me 64. So 8 is multiplied by itself to get 64. That's not my answer. That is not what I want to type in here. That's my h. So now I'm going to go a equals, and I can take half of 6 or half of 8. It really doesn't matter. So I'm going to go half of 6 is 3. 3 times 8 is 24. If I did half of 8, that would be 4. 4 times 6 is 24. So either way, I'm going to get the 24. The last piece I do need to include is the unit. It says be sure to include your unit. We started with m, which is meters. When I'm dealing with length, that's just one dimension, so that's why we just see meters. When we're dealing with area, that's 2 dimensions, so we need to show that it's 2 dimension by squaring it like that. So it's meter squared, because we're dealing more with like length times width. All right, let's go to this last one here. So a square has a diagonal that is 34 meters long. What is the area of the square? So we're still dealing with area a little bit. Now it's asking us about a square, so we need to apply the properties of square that we know. So a lot of these geometry pieces just kind of keep coming back. We practiced square quite a while ago, but now it's coming back. We need to remember that a square, number one, all of the side lengths are the same. Right, so we have 34 here in the middle, but then we're going to have s, and instead of s, I'm going to use x because my s's look like 5s. I don't want you to think I'm writing 5 there. So we have x, 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 x. Well, if I want to know the area of a square, the area of a square is length times width. It would just be x squared. But that doesn't really help me. I don't know what the x's are. But if I'm looking at Pythagorean theorem again, because this is a right triangle, that's another fact or another thing that I know about a square, is that this is a right angle. I'd have a squared plus b squared equals c squared. A squared plus b squared equals c squared, like this. So now I have x squared plus x squared. Well, that's just 2x squared equals, and I'm going to go over here because I do not know 34 squared. That is not one that I have memorized at all. Oops, not 22. All right, so I get 1,156. Before I take the square root, I want to divide both sides by 2 because I don't want that 2 there anymore. I want it to cancel out. So I'm going to come over here and go divided by 2. I get 578. Now I can take the square root of both sides. So I have x equals, that's not what I meant to do. Silly me, I'm clicking the wrong buttons here. I want the square root of that. So we have 24. I don't want to round this yet. And actually, I'm going to put it back in just a minute because I want the area of the square, right, of the area of the square, not just the triangle. So the area of the square, remember, that's x squared. So really, I didn't even need to take this last step, did I? The area equals x squared, and x squared equals 578. So the area is 578. That's transitive property a little bit there. I can jump around. But I can also just say, okay, well, this is the length of x, and then I would square it because I would multiply by 2, not multiply by 2, but multiply by itself 2 times, and I would come back. The only problem with this is it did round it a little bit because of the square root idea. So it said round to the nearest whole number because it assumed that you would go down and find that, the square root of 578. But we want 578, not 577.99999. And they already gave us the unit on this one. Alrighty, so that was section 2. I will see you in section 3.